In this video, we are going to learn about the architecture, requirements, and database design of the placement cell portal full stack application. This is the full stack application which is expected to be completed in week 2 of our ongoing on-job training. This is video 1 of 5 in which we will be covering Node.js, Express plus MongoDB. What are we going to cover in this video? First, we will talk about the full stack architecture. How the entire thing starts from client, then via API, goes to the database layer. Then we will discuss the project overview. What is the placement cell portal? What exactly are we building? The requirement and roles of different users in our system, be it admin, student, company, who does what. Then the database schema design. And at last, we have 2 live coding sessions. In session 1, we will be doing the project setup plus the Atlas connection. And in session 2, we will build all Mongoose models and verify that they exist via Compass. What is a full stack architecture? It has 3 layers that talk to each other: the front end, back end, and the database. The front end is responsible for sending HTTP requests, displaying the responses that it gets from the backend, and handling user input. Coming to the backend part, the backend is responsible for the entire business logic. It handles the different routes, and it is also responsible for handling the validation and authentication. And at last, we have database, which is used for persistent storage. Since we are going with MongoDB, so we are going to use Mongoose ODM, which is Object Document Mapper. And in Mongoose or in MongoDB, each record is represented by a document and each table is known as a collection. After this video, the other videos will cover Postman. In which we will look into API testing. How are we going to use JWT or bcrypt for authentication and security? GitHub for version control, and Atlas, which is a cloud MongoDB. As part of our week 2 OJT application that we are going to build, it is placement cell portal, a real business system that directly supports student employability. So inside this system, we are going to have 5 modules. The first module is the student module. The second module is company module. Then we have application. Then we have the admin module, auth module. Inside student module, it has profile and skills, resume link, eligibility status, and application tracker. In case of company module, it has company profile, job postings, applicant review, and shortlist management. In case of admin, the admin can verify records, can look into the dashboard statistics, can manage all data, and can handle the reporting part as well. Coming to the auth module, it includes login or register, role assignment, whether a user is an admin, a student, or a company. Then it handles JWT tokens. JWT is JSON Web Tokens. And also we are going to look into what are protected routes. This same architecture can adapt to a library system, an inventory system, or attendance system. Now let us look into the requirements and user roles. Every business app begins with users, permission, and data. In our placement cell portal, we have admin, student, and company. So these are the different user roles. Admin can manage student, companies, or jobs. Student can create and edit their own profile. Company creates company profile. Then we have mentor or trainer who can view the placement reports, monitor student progress. So these are the different roles in the placement cell portal. And here we have listed down a few a few of their activities which they will be able to do inside our placement cell portal. As we have looked into the full stack architecture, we have a front end and then we have a back end. The layer that connects the front end with the back end are known as APIs. So we are going to use REST APIs. Now REST APIs are the contract between front end and back end. Primarily, you are going to use 4 HTTP methods. These 4 HTTP methods are get, post, put, and delete. To fetch data, use get. To create data, use post. To update data, use put. To remove data, use delete. One thing that everybody should remember is you must have a consistent response format. That is, each of your API must return the response in this format, which is it must have a success key and a data key in case of successful response, and it must have a success key and an error key in case of a failure response. Again, I'm repeating, each API must return the response in a consistent format. No APIs should have different formats, because if you have different response formats, then it becomes challenging to handle the response on the UI or the front end. Now let us talk about the database design. So here we are comparing SQL with MongoDB. Now MongoDB stores document in collections. It is very important to plan your data shape before writing a single line of code. Don't directly jump into the development part. First, think through it. Once you have thought through it, create a layout or the thinking model of how exactly your collection will look, and then go to the development part. So in case of MongoDB, it has collections of documents. Then it has the flexibility to nest two objects. In MongoDB, you can either embed or reference. You can either use embedding or referencing. Now, what is embedding and what is reference? We will see in the further slides. MongoDB can scale horizontally. It is good for rapid development APIs. So, our 5 collections for the placement portal are students, companies, jobs, applications, and users. Now, these are the key fields for students: name, email, skills, CGPA, and resume URL. Similarly, these are the skills for companies. These are the key fields for jobs. These are the key fields for applications. And these are the key fields for users. This we have already talked about the collections in the previous slide. Now let us look into the relationships. First, we have our student collection. It has many applications. One rule it must follow is that email must be unique. Then we have company collection. It can post many jobs. It is the source for job postings. Now, coming to the job belongs to a company. It can be filtered by skill or category. Then we have application. Here in application, we are making use of student ID and job ID. Now, this student ID is referenced from the student collection, and the job ID is referenced from the job collection. Status: applied, shortlisted, selected, or rejected. It joins student collection and the job collection. And at last, we have filter collection. The relationship is it maps to student, company, or admin. Role drives access control. What are the collection relationships and how data links together? This we have already talked about in the previous slide. So when we talk about user maps to student. Then we have company. Company posts jobs. Student applies to application. And as I said earlier, what is the difference between embed and reference? So when we embed, that is data always accessed together. Example, skills inside a student. And when we reference separate updates needed, example job ID in application. So what are we going to do in the live coding session 1? The task is to do project setup and Atlas connection. So here we will be creating folder structure, installing packages, then connect MongoDB Atlas. The steps which are listed down, these are the steps one must follow to complete the live coding session 1. Okay. Now let me do this. First command is mkdir placement portal and change directory to placement portal. So I'll go to VS Code. I have already opened the integrated terminal. So this is VS Code's integrated terminal. The first step is running mkdir. Let me zoom it a bit. Create placement portal directory and change to placement portal directory. Here it is. Now I am inside placement portal directory. So the first step is complete. The first step is completed. Second is we want to do npm init -y. Let me do that. npm init -y. So what we have done is we have initialized our project. The name of our project is placement portal. Its version. The main file is index.js. As of now, there are no scripts, keywords, author. You can put your name, license, and the type of the project is common.js. So step 2 is also done. Then we install the dependencies. Those dependencies are Express, Mongoose, .env, and cos. Those dependencies are Express, Mongoose, .env, and cos. Let us do that. The command is npm install Express, Mongoose, .env, and cos. This may take a while, as it is fetching packages from the npm repository. Here it is. Now let me just open this directory. So I'll click on open folder, and here I have desktop, then we have GitHub. So in GitHub we have YouTube videos, placement portal. As you can see, when we did npm init -y, so it has created this package.json file, and after we have done npm install express mongoose.env cos, it has created this node modules directory. Let me open the terminal again. So we are done with installing the dependencies as well. Then we are going to install node mod. Look at this -d option. What it signifies is we are going to install node mod as a developer dependency. So inside package.json file, here you can see dependencies. Now once we have ran this command, npm install -d node mod, then after dependencies, here we will see dev dependencies. Let us do that. npm install -d node mod. Here it is. Inside package.json, dev dependencies, node mod. So we are done with this step as well. Next is we are supposed to create folders, models, routes, middleware, and config. Let us do that. You can create folders from the file explorer, or you can create folders from the terminal as well. So we are supposed to create folders, models, routes, middleware, and config. Let us do that. mkdir dir models Browse. This is where models is done. Then we have routes. Routes is done. As you can see, as I'm running the commands, the directories are getting created over here. Models, routes. Then we have middleware and config. So middleware, middleware. Then at last we have config. So config, we have created all the folders. After that, next step is to create db.js file inside config. Let us do that. Here I am in config. Click on new file. Name it as db.js. Later on, we'll write the code into this file. We are done with this as well. Then we have create server.js entry point with app.listen. So at the root level, create a file server.js. Code for this also will be added later on. At last we have, okay, once then when we run node server.js, we should see MongoDB connected in the terminal. But prior to that, let us populate the code inside db.js and server.js. So this is going to be our project folder structure. The importance of this project folder structure is it is organized by feature from day one, easier to scale and review. Why this layout? So inside config, we have the database and EME setup, which is isolated. Inside models, all Mongo schemas in one place. Inside routes, one file per resource, easy to find. Then inside middleware, we have auth logic, which we are going to reuse across routes. And at last, inside the .env file, we are going to store secrets, and this will never go in source code. That is, we are never going to commit the .env file. This is going to be the project folder structure for placement portal. In the previous step, we have only created the config directory and inside that added a file db.js. It is required from each one of you that when you complete the live coding session 1 and 2, you must have or your project folder structure should look identical to this. Now let us do or create our first student collection, which will go into the models directory. A schema defines the shape and rules of your documents. A schema defines the shape and rules of your documents. So inside models, let us create student.js file. Now in this file, let us populate this file with the code. So first we are going to require mongoose const mongoose is equal to require values. Remember, we have installed mongoose using npm install. After that, we are going to create a student schema const student schema is equal to new mongoose dot schema, and here we are going to define our schema definition for student. Remember, the key fields for student are name, email, skills, CGPA, resume URL, and eligible. Let us do this. Name, its type is string, it is required. Email, type string required, and one condition that email must be unique, lowercase must be true. Skills, it is an array of string. CGPA, type number, minimum 0, maximum can be 10. Resume URL, again type string. Eligible, type boolean, default is true. And then at last we do model.exports equal to mongoose.model student schema student collection followed by the schema definition. So first we have name, right? Its type is string and required. Yes, it is required. Then we have email. Its type is also string. It is required. Let me check whether it is required. Yes, required is true. Then it must be unique. Unique is true. Lowercase is true. After email, we have skills and CGT. So in case of skills type, a student can have multiple skills. Hence, we are using an array of strings. Is it required? Yes, it is required. Then after skills, we have CGPA. CGPA's type is number. Its minimum value is 0 and maximum value is 10. Then we have resume URL. Resume URL, its type is string. So in case of skills, we have missed out one thing. It is not required, whereas the default assignment for skills is an empty array. After resume URL, we have eligible. So by default, all students are eligible. Type boolean, default is true. And then, okay, that is done. Timestamps true. After we have defined our schema definition, then we are going to export this to logos dot model, which is student schema goes dot model student followed by the student schema definition. This is one example in which we have created our student schema. We have created our student schema. These are the key fields of our student schema, and this is how you export the Mongoose model. Similarly, you are supposed to do or write the schema definition for user, company, job, and applications. Required true implies the field cannot be empty. When it is passed empty, it will throw an error. Unique true, it implies prevents duplicate emails in database. Type string, array of strings for skills. Min and max validates CGPA range within 0 to 10. Timestamps true, it adds created at and updated at automatically. Model.exports makes model available across the application. As we have did for student schema, similarly you are supposed to do it for the rest of the schemas. Connecting to MongoDB Atlas. But prior to connecting to MongoDB Atlas, first you are required to do the Atlas setup. First, you are required to do the Atlas setup, which involves creating a free Atlas account. Click on New Cluster, M0 free tier, then database access, add username and password, network access, allow all, and click on connect, copy URI into the .env file. So if you remember earlier we have added db.js. Now inside that db.js, let us write the logic for connecting to the MongoDB. So first line is, so we have, let me open db.js, there it is. Let me require const mongoose equals require mongoose. Second is, we are going to define a function const connect db is equal to, it is an async function. Then inside this, we are going to make use of try catch. Inside the try block, await mongoose dot connect. We connect to process dot MongoDB URI. Now this MongoDB URI will come this MongoDB URI will be set in the .env file or the environment file. Then we do console.log connected to OCOD. And inside catch, we are going to do console.error. The statement would be connection failed. And what was the error? And at last, when the connection fails, you will stop the server using process.exit1. Let us just export this function. So this is our connection logic, but for this, you must have a MongoDB URI. You must have a valid MongoDB URI. In order to have a valid MongoDB URI, you must follow these steps. Now let us do this. Let us go to atlas.mongodb.com. Let us go to just close this. Let's go to atlas.mongodb.com. It seems the internet connection is a bit slow. Here it is. Now click on sign in. So you can make use of either Google or GitHub account. I'll make use of, say, GitHub account. That did not work. Let me try with Google. First go back. Again go back. Take on Google. So after clicking on Google, let me select this account. It should sign in. Okay, signing in. Click on accept privacy policy. I accept. Click on submit. Now we are into MongoDB Atlas. The next step is, let me just open the presentation. Yes. Next step is to create a new cluster, M0 free tier. Let us do that. Create a cluster. Create. So it will be, let us call this as, let us name the cluster to be Vadia OJT, Vadia on job training. We are going to use the free cluster. Make sure you select the free cluster and not any paid ones. So it is going to be, the provider is AWS, region Singapore. Then okay, create deployment. After clicking on create deployment, so this will then give you your current IP address has been added to enable local connectivity. Okay. Create a database user, username, password. After this, you click on choose a connection method. Set up user security permissions. Okay. Create database user. User is created. After that, you click on choose a connection method. When you click on choosing a connection method, just explore these different options. Explore these different options. However, in our case, we are going to use MongoDB for VS Code. Click on this. So this will give you in VS Code open extensions. Okay. Yes, here it is. So this is our MongoDB URI, which we are going to use to connect to our MongoDB database. Let me copy this. I have copied this. Now if I go to VS Code, I'll create a new file. Okay. From File Explorer at the root level, let me create .dnv, and inside .dnv, I'm going to add MongoDB URI, which is equal to this value, which I have just fetched from MongoDB Compass. I have added that. Click on Done. Now, since I'm going to connect to this MongoDB from my system, so by default, it will allow. If it doesn't allow, then all you have to do is just go to Network Access and allow all. After that, copy URI into env file, which we have already done. So, Atlas setup is completed. After this, we are going to add code into our server.js file. Let us do that. First is, we require Express, then our connectDB function. So inside server.js file, the first step is to require Express. Now Express is a framework which we will talk about in later sessions or in later videos. Then we require our connectDB. On this connectDB is inside config/db.js file. Then we have our application. So const app is equal to express. After that, app.is express.json. Whatever the steps that we are doing right now manually, all these steps can be done while we use Express generator. But instead of directly jumping to the ready-made stuff, first we are doing it manually so that we get to know how exactly everything is working, how things are interlinked to each other. Then we will jump onto the Express generator framework and we will be able to comprehend how easy the Express generator makes our life. After that, we call our function connectDB. That is connectDB. Then we are going to make our app listen on port number 5000. App.listen, listen on port number 5000. The callback function. Now this callback function will return console.log saying server running on port 5000. So after this, now let us do node server.js. Let us try to run this code or run our project. Node hit VM install. In my opinion, this code will fail at connectDB because here we are trying to read from process.env file. However, we haven't made use of the .env package. So const.env, because .env helps you to read environment variables. Require.env and do .env.config. That's it. Don't pass any options. Doing these two, that is importing a .env package and then doing .env.config, will load all our environment variables into the node's running context. Then this will be made available, or inside db.js, we'll be able to access MongoDB URL. If you don't require .env and do .env.config, in that case, this field will return undefined and you will not be able to connect to the MongoDB. So now let us do node server.js. So here it is. injected env server running on port 5000. After that, we have also called connectdb, but connectdb has not recalled anything. That means the connection to database has not succeeded yet. Prior to that, let me add a console.log here. Console.log db URI is we have an error, that is we are not able to connect to the database. But prior to that, let me see. This is the error. What the error says: connection could not connect to any servers. One common reason is that you are trying to access the database from an IP that isn't whitelisted. Since we skipped this step, hence it is not allowing me to connect to the MongoDB. So let us do that. Go to Compass. Here I am. Edit configuration. Did additional configurations. Cluster capacity, additional settings. Turn on backup, no. Cluster details. Okay. Again, go to the home page. So where are the clusters? Users, applications, teams, AI models. Oh, just give me a second. Let me just Google how to enable all IPs to connect to MongoDB via Access. Configure IP access list entries. Okay, for AWS. In Atlas, go to the project settings page. In Atlas, to the projects settings page. Where is settings? Okay, we have project 0, actions. Visit project settings. Okay, and in project settings, project activity field page. So in project settings, we have to go to the project activity field page. Let us do that. Where can we find project activity field? Or check project activity field. Let me search that. Activities field. Okay, here it is, activity field, and inside of activity field, okay, required access. Inside of activity field, to do that, think this is not the page. We go back. Project name, time zone, tags, maintenance window, collect database specific backup, project overview, security quick start, machine IP address, database monitoring tools, data explorer. Okay, let me click on project database and network access. So inside security, we have database and network access. Okay. IP access list. Now from here, you will only be able to connect to your cluster from the following list of IP addresses. Click on edit, access list entry. What we have in the presentation, it should be this 0.0.0.0/0. Let us do that. 0.0.0.0/0. Okay, this access list entry potentially allows access to all IPv4 addresses. Great. Let us click on confirm. Status is pending. Once this status is confirmed, again we'll go back to our project and run node server.js to see if we are able to connect to the MongoDB. Here it is. The status has gone to active. Now let me go to the presentation, slideshow mode. Done. Now coming back to the terminal, node server.js. We are getting the DB URL as expected from the env file. Server is running on port 5000. It has called the connect DB function. We are seeing this console.log on the terminal. Now, after this connection succeeds, we should see connected to MongoDB. Let us wait. Okay, what is the error? It says could not connect to any servers. One common reason is that you're trying to access the database from an IP that isn't whitelisted. Make sure your current IP address. It should accept. It should, because we have whitelisted it, or anybody can access the database. Without access, okay, anybody can access. Click on advanced. I think these are all not needed. This IP access list should sort it out. If not, then I'll post the solution in some other video. Okay, again it is not connecting. Let me just try this at last. I have been enabled. Disconnect. So I am right now disconnected from VPN. Now let me try accessing this. There it is. Now it is connected to MongoDB. As I was connected to VPN, thus it was not able to establish a connection to the MongoDB database. But after disabling the VPN connection, it is now able to connect to MongoDB. So now what's remaining from your part or your end is, so for the session 2 part, you are required to create, this is already created, create user model, company model, job model, application model. And then you should be able to see when you run node server.js, MongoDB connected in terminal, which we are seeing right now. And at last, open MongoDB Compass, verify collections appear after first insert. Since we have not inserted anything into the student schema collection, so this will not appear in MongoDB Compass. But when you enter one document into any of these schemas will appear. These schemas will appear. Sure. If I go to database clusters, these schemas will appear here. As of now, there are no collections, hence we cannot see any collection. But once we create or insert a record into a collection, that will appear here. How can we test that our models are working? So what I'll do is, inside server.js, I'll add this code. Inside server.js, I'll add this code. Let me copy this. Think it should be copied line by line. Instead of that, and directly type this code. So what I'll do is, let us create a test. Let us create a function test student. And from within that function, we will call or test student insertion. After connecting to the database, we are going to insert a test student. What is that? Const test is equal to await student dot create. Now this will take in name and the name of the student to be John Doe. Then email is jdoe@gmail.com. After email we have skills. Remember, skills is an array. So skill has JavaScript. No more JavaScript. After that we have John Doe has skills, Golang. Then say Rust. So these are the skills of John Doe. CGPA for John Doe is 9.5. Then after this we do console.log student created and we log in the student's ID s.id s.the_id. Now let us restart the server and we should see that a student must be inserted into our MongoDB collection. So here it shows student created, new object ID. Now let us go to our compass and verify that we have our student collection. Clusters, OJT. Where can I say collections, stream services, project overview. Okay, browse collections. So here we have Vadia OJT and inside Vadia OJT there should have been a student collection. Here I mean local test came. Here it is. So here we have the test DB and inside test we have our student collection. And inside student collection, this is the record which we have inserted just now. Hence, we are able to test or insert a test record into our MongoDB successful. Let me go back to the presentation. So what we have done, terminal shows MongoDB connected, no errors on model import, console logs IDs after create, compass shows the document in collection, and let us verify the timestamps created at or updated at are those present. So in compass, here we have created at and updated at. Both these values are present. These may be the common errors that you may encounter. And here I have also put down the solutions to these common errors. So video 1 recap, what you have built today or what we have completed in this session. First, we have explained the full stack architecture, that is the 3 layers. Then we have mapped all requirements and user roles, designed 5 collection database schemas. I have designed only one, the rest 4 must be designed by you. Created all Mongoose models with validation, connected to MongoDB Atlas, verified data creation in MongoDB Compass. In next video, that is video 2 of 5, we are going to look into REST API with Express and Postman testing, in which we will cover the Express router setup, all 5 CRUD routes per resource, try-catch error handling, HTTP status scores, and Postman collection and testing. Your tasks after this video include, if you want to be at the basic level, do this. If you want to stretch your understanding, do this. And if you want to submit that you have done something, then do this. That is, push your code to GitHub. So video 1 is completed. I hope you would have learned something valuable. If yes, please do like, share and subscribe. And in the next video, we are going to talk about REST API with Express and Postman testing. After that, we have front-end, integration, and at last, we will talk about authentication and them. Thank you all.